any
Okay. Yes, sir.
horizontal line intersect the graph of a function f in at most one point,
Yes,
okay,
sir.
then the function is 1 1. So what is the problem with this option?
Uh, Sir, it is saying any horizontal line, sir. This option must not be true because
It's, but at the same
all,
time it's saying at most 1 point.
yes, sir.
Hmm.
What I am saying, sir,
Hmm.
if one horizontal line cut at most 1 point,
Hmm.
then every function will be 1 1. If we say that this option is true, then every function can be 1 1.
Wow,
Uh,
wow. Yeah, okay, just let me, just give me a minute, let me share my screen. Uh,
Actually, sir, there should be all horizontal line must be cut at 1 point.
no,
Then only.
no, it's depend on the domain of the function, right? So if the domain of the function is basically from uh, uh, 1 to some, if you have a function from, let's say,
Sir, you
from
are
maybe,
not audible now.
am I audible now?
Yes,
Hello?
sir. Yes, sir. Yes, sir.
Yeah,
You
so,
are you.
so
Yes, sir.
so if the domain of the function is, let's say, from -1 to 1, okay, so f is a function from -1 to 1, okay, and let's say this function is basically x goes to x, right?
Yes, sir.
So this is a 1 1 function, correct or not? This is a
Sir,
1 1
x
function.
goes to x means one-to-one correspondence.
X goes to x. So this is the domain. Domain is basically -1 to 1, right? The
Okay.
domain of the function is -1 to 1. If I draw the graph of this function, okay, what will be the graph? So, so as you can see, just I'll just take some part of this function x equal that y equal to x line, because my domain is basically -1 to 1. So this is -1. Uh, this is 1. Okay, so I can't take all the things. So I have to take only this part. Okay, this part. This is my 1 1. This is my -1 -1. Right. So this is a 1 1 function. Okay. If I take this line, this horizontal line, let's say. So if I
Sir,
take this,
actually,
just a minute, let me complete. Okay. So if I take this horizontal line, okay, so then it will not intersect this graph, but still this function is 1 1. Yeah. Now we can proceed. What you want to say?
sir, suppose we take a cubic function, a many one cubic function, then there are many horizontal line which cut only one time.
Yeah, that is fine. Like, but certainly this is not violating whatever is written in the question. It's saying its horizontal line will cut at most 1 point. So if it is cutting at 1 point, then no issue. We are fine.
Sir, we are fine, but that is not, we cannot claim that is 1 1. We are fine, that's okay, but that is not guaranteed that function is 1 1. And that statement actually claiming that.
No, no, no. Tell me which one
I
you are.
would, sir,
Huh?
sir, if you
Yeah,
allow,
just
I would also like to share my screen, sir.
no, I can't. That you tell me what
Sir,
is the
then please
what
graph a cubic equation, a
uh,
many one.
which one you are talking about? Let look, which cubic equation?
Okay, sir. Suppose there is two roots, 4 and 5, sir. Please draw a graph.
Two roots, cubic, or you are saying quadratic?
Sir. Cubic two roots, repeated root. At 4 there is repeated root.
Okay, so basically, suppose you take this polynomial f of x equal to x minus 1, x minus 4 square,
Yes, sir. X minus 5.
x minus 5, right?
Yes, sir.
Uh, uh, yeah, so then what will be the graph? Okay, so this is more or less, you have two roots. 1 is 4, 1 is 5, and this is okay. So the coefficient is positive, so it will come like this. It will go again. It will come like this. Go like yeah. This function is not 1 1, right?
Yes, sir. This is not 1 1, but if
Yeah.
we draw as a statement say that
Hmm.
if any horizontal line, so suppose draw y is equal to 2, sir, or line y is equal to 2,
Uh,
horizontal line.
yeah.
Please draw, sir.
Uh,
Uh, and the statement is what is it is claiming, sir.
but if I draw this line,
It is cutting at most one point.
no, if I draw this line y equal to -2, let's say, okay, this is my
Yes,
line.
sir.
It
Yes,
is
sir.
cutting. It is cutting at 3 points, right?
Y is equal to -2.
It's cutting at 3 points. This is 1 point. This is 1 point. This is 1 point.
Yes, sir. This is
So
cutting at 2 points. So for
this is
this,
cutting. Yeah, but
yes,
so that is so it's saying in the question it's saying any line. So it should satisfy for all the line, not for some specific line, right?
sir, there should be all mentioned. No,
No
any
that
line
no
that is
that
a
is
line. The upward line x is equal
okay.
to
So
2 is a any line.
okay, you need to think. Okay, just need to think. Any line means you are basically saying for any arbitrary line it should hold, right? So but what you are saying so it is not given that for a single line. It's clearly mentioned that it should hold for any line. So if I draw any line, it should hold for that line, right? What do you mean by any line? I'm not mentioning a fixed line.
Any
You are
line means if one line satisfied.
no. That is the problem. Like you are interpreting it incorrectly. Okay, that's what I'm saying.
Why, sir? Sir, suppose
Okay,
let me
okay.
say
So okay.
another example.
Just okay.
My request here, Subhashish, we're already 15 minutes.
Yeah.
Can we please
So,
get back to the scope of this meeting, please? Thank you.
yeah. Thanks. Okay, so I'll suggest you to please think a little. Okay, so any line is basically it's saying that it's hold for any arbitrary line. Okay, so but when you said that this is hold for this line, then you are specifying a particular line. Okay, okay. So let me go back to week 4. Uh,
Yes, sir, I have a doubt in week 4.
mhm.
Sir, 5 plus 5x raised to power 0 will be monomial or binomial?
5.
5 plus 5x raised to power 0.
5 plus
5x raised to power 0.
should be a monomial.
Okay, so we will first we will solve the equation if it can be solved, and then we will find if it's monomial or binomial.
Yes.
Okay, sir.
Basically it's 10, right?
Yes, sir.
Because x power 0 is 1, and you are basically adding 5 plus 5, which is uh, 10. Okay, so let me uh, let me start something like is there anything you want me to discuss, or something you have doubt, like you can ask.
So I have a doubt. Hello,
Hmm.
good afternoon, sir.
Yes.
So I have a doubt. Can we plot imaginary route on coordinate system, sir?
No, okay. So the problem is you can't. So that is actually certainly it's impossible to draw, because what is the advantage when you are drawing a function from R to R, right? So R to R, when you are drawing a function, okay, so the advantage is actually you can completely represent this function. Okay, in some sense, let me tell you, in some sense, I'm using some word. Okay, this has some different meaning. So in some sense, R is one dimensional. Okay, so if I have a function, okay, I can
Okay,
draw
sir.
I can draw in a two-dimensional plane, right? I can
Yeah,
draw
sure.
a function in a two-dimensional because this is one-dimensional, this is one-dimensional. And when
Yes,
I'm
sir.
representing, I can represent this as x plus x point f of x. So I can represent it in a two-dimensional plane, correct?
Sir, yes, sir.
Uh, but the problem is when you consider this function from C to C, complex to complex, okay? So
Yeah,
then
sir.
this is a two-dimensional thing, right? Complex is basically two-dimensional thing, a plus bi, right? So, and this
So
is
we can
also,
represent complex number in coordinate system.
you can represent complex number, okay, but you cannot represent the graph of a complex function, okay, but because when you represent a complex function, then what you have? You have f of some, let's say c, some complex number, right? And you
Yeah,
have
sir.
f of c, okay. So then basically in some sense you are in 4 dimensions.
I did not get it, sir. Like, I did not get anything. What is
No.
for?
Yeah, that is what so the thing is so what that is what I am saying. So this r, okay, this is a one dimensional thing, right? This
Yeah,
is
sir.
a one dimensional thing. So when you represent this point, okay, to draw the graph of f, graph of this function f, okay,
Yeah, sir.
you have to draw all the points, right? You have to specify all the points x comma f of x, and
Yes, sir.
then you join all those points and you will get a graph, okay.
Yeah, sir.
So this first coordinate, this is a real number, right?
Yes, sir.
So this is a one dimensional thing, right?
Yeah,
So
sir.
this is also f of x also is a real number, okay.
Yeah, sir.
So then you are still also in one dimensional. So when you combine, you are in the end you are getting a two dimensional thing, right?
Yes, sir.
But when you are in complex number, okay, so when you are complex number, then basically you are in two dimensional thing. So C, so if you take C, the complex number is actually a two dimensional object, okay. So when you try
It
to,
is two-dimensional object, sir.
so because how you represent complex number, okay, you need two things, right? A plus bi, right?
Yeah, sir.
So this is A is a real number and B is also a real number. So basically you need two things to represent a complex number. So that's why it's a two-dimensional object.
I think it does not affect much on like present content, no, sir. Maybe we study it later.
Yeah. So you'll see. So the thing is, you can talk about zero, but certainly it's not possible for you to draw the graph. Okay. So you certainly can't
So if a
represent.
polynomial contains a real imaginary root, then the polynomial does not have any graph.
Certainly it has, maybe it has some graph, but certainly we can't draw it. Okay. Certainly we can't draw it in our pen and paper. Okay. That is
2D.
not possible. Yeah, 2D. Correct.
So if a polynomial contains like if like okay, if there is no like there is no representation of a graph which contains a complex row, sorry, a imaginary root.
Correct. So when I'm drawing this graph, okay, when I'm drawing this graph, this is basically the real root. Okay. So if,
But in lecturer videos, we drawed a graph. We thought that it may contain some like imaginary roots which does not touch x-axis.
no. So it may have. I'm not saying that it certainly doesn't have. Okay, this polynomial function, whatever this function is, this may have some complex root. Okay, but certainly I cannot tell anything just by looking at the graph. Okay, it might have some roots in complex, but just by looking at the graph, I can only tell that this graph has only one real root. I don't know about the complex root. Okay.
It may have.
It may have. Okay. So okay,
We will draw a graph.
let me take an example. Suppose you have, so the thing is, suppose you have this quadratic function, right? So
Yes,
suppose
sir.
you have a quadratic function, ax square. Let's say
Yes, sir.
some quadratic function,
X
x
square
square
plus.
plus bx plus c, right? So
Yeah.
so actually there is a theorem. It says that this quadratic function has two roots, okay, but it doesn't tell you whether this quadratic function has two real root or complex root. That certainly you have to find. So suppose if I draw the graph, okay, so if I draw the graph, if the graph is something like this, okay, let's say if the graph is something like this, okay,
Yeah, sir.
that means it has no real root.
Real roots.
That means it has two complex roots.
Two complex roots. But we are
Because
drawing
yeah. But okay, so again, like since we know that this quadratic function has two roots, but we don't know whether it is real, completely real or completely complex. Okay, by drawing the graph, we can see that this has no real root. Okay, so that means it has two complex roots. Okay, so it will have
so
some.
we can draw a graph for a polynomial containing complex roots.
No, we can't actually. That is
But
what
we're not drawing, no, sir. But we now right now we are drawn, no.
this is the real representation of the graph. This is the real representation of the graph.
Okay, only we will represent, but we can't draw in real.
No, this is the real representation of the graph. This is not the complex representation of the graph. Okay. I'm drawing in. So this is basically the real. So when I'm considering this function, okay, from
Yeah, sir.
R to R, okay, when I'm considering this function from R to R, then this is the graph. Then this is the graph. Okay. But when I consider this function, I can consider the same function from C to C, right? Complex to complex also, right?
Okay, sir.
But in that case, I can't draw the graph.
Okay,
Because
sir. If it is range and domain is a real number set, we can draw it. We can represent that.
yes, correct.
It may contains imaginary roots.
No. How from where you will get the imaginary root? So the imaginary
In one lecture video, sir, drawn a graph. He said that we only know roots. We can only see real roots, but it may contains imaginary roots, which we can't see.
Yeah, that is what. Because why you can't see? Because the problem is you are drawing the graph of the function
From R to R.
from R to R. Okay, so you are drawing from the graph of the function when you are considering the function from R to R. Okay, it may have complex root, but just by looking at the graph you can't say that. Okay, so because you are drawing on a real line.
It's really confusing, sir. It's okay if if I did not get into deep, it's okay for now.
Yeah, it's fine. Okay, no problem.
I did not also understand why odd function is symmetry at origin.
All function is symmetry at origin. What do you mean by symmetry at origin?
I do not know, sir. In in lecture, it says if a function is odd, it is symmetry at origin.
Not okay. In some sense, yeah, I understand. Like there is no symmetry. Okay, there is nothing called symmetry about origin. But so the thing is, if you have a odd function, okay.
Odd function is never symmetry, no, sir. I think.
No. In some sense, it is symmetry because what is odd function? First, tell me what is odd function.
Odd function if we minus f of minus x is equal to minus of f of x.
Minus x
minus of minus f of x.
Minus f of x. So in some sense, what actually it's saying, okay, so this is your x, right?
Yeah, sir. If x is equal to 0, then...
So this is your f of x. This is your f of x. This height is basically your f of x, right? So that means this point is x comma f of x, correct or
yes,
not?
sir. Yes, sir.
So then what will be the value of the function at minus x?
Minus x comma f of x.
This is basically minus x comma f of minus x, right?
Yeah, f of minus x.
And what is f of minus x? What is f of minus x? F of minus
f of x.
Minus f of x, right? So in particular, this distance, correct? This distance,
yeah, sure.
This distance is same as this distance.
Yes, sir.
So in some sense, that is what it's saying. Like if you draw this line, okay, if you draw this line, so they are basically in some sense they are basically symmetry about origin. Okay, so the same distance from here to here and same distance
only in this particular case.
No, for odd function. For odd function.
Now it is a straight line. We can say by seeing it, it is a symmetry for
No, this is
from our
I have so this I have taken a arbitrary odd function, right?
yeah, sir.
And I proved it for, like, if you see this
Sir,
point.
like if we say if a function is symmetry about x-axis, like we will fold correctly with the x-axis, like we will fold in between x-axis, we will get equal parts. If we say symmetry about origin, how can we fold, sir?
No. So there is a slightly difference with respect to when you are saying with respect to x-axis and with respect to origin. There is slightly difference. Okay. So there you are considering a line. Here you have a
Yeah, sir.
point. Okay.
Point.
So you can fold it. You can't fold it like with respect to some line. Sorry, with respect to a point. Okay.
Point.
That is what I am saying. That's why I am saying the distance is basically same. So this distance, okay, and this distance, they are precisely same. Okay,
Yeah, sure.
so that is what probably the professor means, that this odd function is symmetry with respect to origin.
So can you explain with x cube graph?
Yeah, x cube graph, like if you take this what is the graph of x cube?
It starts from first coordinate and it ends crosses origin and ends into third coordinate.
Yeah, it's more or less like this. So, so there is slightly twist here, okay, in the origin. It certainly is not like that. Okay. So if you take -1, so let's say 2, what you are
Yeah,
getting?
sure.
What you are getting?
8, 2,8.
2,8, right? And what you will get if you take -2?
-8.
-2 minus.
Distance is same.
Yeah. So basically this particular distance, okay, and this particular distance, they are basically same. It doesn't is hold for any arbitrary point. It's nothing
Yeah,
special
now I
about
got it. Yeah, I understand, sir.
nothing special
Yeah,
about 2. Okay.
yeah, I
You
got
see.
it. So thank you, sir.
Thanks. Yeah.
Yeah.
Okay. Anything else?
Yes, sir. Hello, sir.
Yeah. Yes.
Sir, I have doubt in greater sum and big three.
I'll come to that. Okay. Anything from week 4?
Sir, can you explain the stretch factor, please?
Stretch factor is basically it's a constant, right?
Yeah, but sir, there was a question where we are equating f of 0. Like
So it's
if we
better,
have
like, okay, just can you mention the question number so that I can understand what
okay, sir, give me a sec. I'm gonna find the question. Till I'm finding, you can just like get anyone's doubt. So once I find it, you can just get back to
fine.
me.
Yes, sure. Okay, any other question? Okay, I'll come to like week 3 or graded assignment. So let me tell you, in week 3 there are two mistakes. So question number 3 and question number 8. Okay, and so we'll ignore both the question for final grading. Okay, so actually it was pointed out by many students that both of the question can have multiple answers. So that's why we are ignoring both the question for final grade.
Hello, sir.
Yes.
I think the question that he was searching for is in the 4.13 activity, stretch factor.
Yeah, it was the 4.13 last question. Easy, sir. The question in that question, the curve is cutting the y-axis at 0, 8. So that is actually f of 0. And we have like
Just a minute. Yeah. So once you know the y, okay. Let me come to that.
Okay.
4.13. Question number 5. Okay.
This is the
So,
last question.
So one thing you can see that the graph is cutting the y-axis at
0.8.
0.8, right?
Yeah. Yeah.
So what is the equation of the polynomial?
It was x plus 1 into x minus 2 whole square. A into x plus 1 into x minus 2 whole square. That was the equation of the polynomial.
No, certainly there should be some variable a, right?
Yes,
Otherwise,
sir. Yes, sir. I told you, right? Like a into x minus
yeah,
1,
yeah.
x plus 1 into x minus 2 whole square. So we need to find the a.
Yeah, so P of x is basically a into x minus, sorry, can you repeat?
X plus 1
X plus 1,
into x minus 2 whole square.
x minus 2 whole square, correct? So,
Yeah.
so this is the polynomial, and you know, right, you know that this this graph of the polynomial, okay, it intersect this y-axis, whatever this graph, let me draw like this, okay, this intersect this y-axis at 0,8, right?
Yeah, 0.8. Yeah.
So that means at x equal to 0,
Uh-huh.
right? P of
Yeah.
x, P of 0 is 8.
P of 0
right?
is 8. Yeah.
So basically now you just need to substitute x equal to 0 in this equation. Okay,
Yes, sir. Yes, sir. That was exactly my question. So we need to equate the f of 0
Yes, correct.
or p of 0 or whatever the function we are calling. So we need to just equate them and we need to just find it out, right?
Yes, correct. So once you equate, then you will get the value of a. So that is a times 1 times 4. So in that case, a is precisely 2.
Actually 2.
Yeah.
Yeah. But sir, what if we don't have a graph or something? That's the question. I mean, I was
No.
about to come to that
So
question.
the thing is, if you don't have any information like this, then certainly it's not possible for you to get the stress factor. Okay, so
Yeah.
yeah, so you must have some information
okay,
that you can that you can use to get the value of a. Okay, so here you have some information.
Okay,
So the thing is, so there can be any multiple possibility of a, right? If nothing is given, okay, can be 2a, can be so if something is given, then there will be a unique value of a. So it is given, right, at
yes,
the value.
0.8.
So then in that case you will get a unique value of a. So if nothing is given, then it's not possible for you to get a unique value of a.
Okay, so the bottom line is, if we get a problem like this, we are going to get a corresponding graph to it, right? So if we need to find a unique value of a,
so the thing is, if only the graph is given, then you can't conclude anything. So if you see in this question, so along with the graph, the coordinates are also given, right?
Yeah.
So if the coordinates are given, then probably you can find the x-intercept or maybe y-intercept, and after using after knowing y-intercept, then probably you can find the stress factor. If some vague graph is given, then if the graph is given something like this, but the coordinates are not given.
Oh, so without coordinate, without coordinate, we can't say that at which point
So
the intercepts are happening. So yeah.
Yes.
Okay,
So
got it.
without,
Got it, sir. Thank you.
Thanks. Okay, any other questions? Any other question or maybe some concept you want me to discuss? Sorry? Hello?
Sir, I graded some question number 2.
Week 3.
Yes, sir.
Solution, have you checked the solution or not? Like,
Sir, solution is not given in port.
solution is not given. Okay.
Yes, sir, not available.
Just give me a minute, let me check. Okay, yeah, it's not given.
Sir, according to question, I found line 1 and 3 are parallel, but in answer they give line 1 and 2 are parallel.
Okay, let me check. Let me check. Just give me a minute. I'll solve this question completely.
Okay, sir.
Okay. Okay, so I guess the answer is correct as far as I know, but let me solve it. And so so you have two parabola. Okay, so
Yes.
number 2. So you have two parabola y. So y equal to 1 is x square plus
3x.
3x plus 2, and another one is y equal to minus x square minus 5x minus 4. So this parabola is basically open upward, and this parabola is open downward.
Down. Yes.
So it's given that this parabola is intersecting at 2 points. Okay, so 2 points A,
Okay.
and for A it is mentioned that A is not on the
On the x-axis.
x-axis. So can you tell me what are the points A and B?
Is B is B on the -1 0 and A in somewhere the second quadrant.
Can you tell me the coordinates of A? Or
Yeah. For
Minus
y equal
minus
to
3
x
comma 2,
square.
sir.
just a minute. Okay, so suppose this is the first one. Okay, maybe say
No, sir, both parabola is in
both parabola.
second and third quadrant, not in first and fourth.
Not in first and
Yeah.
fourth.
Means that x.
So what you are saying? Okay, so I'm just don't take the graph seriously. I'm drawing some vague diagram. Okay, so for that I have to draw a lot of things to draw the complete proper graph. So okay, so can you tell me the points A? What is A and what is B?
B is -1 comma 0.
B is say -1 comma 0. So B is this point. B is -1 comma 0. Okay. And what about A?
-2 comma 3.
-2 -2 comma 3. So we are saying this is basically on
Third quadrant.
no, how come -2 comma 3 in third quadrant?
The second quadrant, sir.
Sorry, second quadrant. Yeah.
Okay, both the parabola they are intersecting in the second. Okay, just a minute, let me check.
Yes.
So intersecting at 2 points and B. Okay, so you are saying A is -2 comma 3. So if I substitute -2 here, what I am getting 4, right? Plus -6
+2.
plus 2. So
0.
this is precisely 4 minus 2. 4 minus 2, it is 0, right?
Yes.
So then how come minus 2 comma 3? Minus 2 comma 3 is not in the parabola.
Sir, it's minus 3 comma 2, the point of the coordinate of A. Sir, one thing is for sure, we can just equate these parabola equations to find the point, right?
Yeah, that is certainly you can do. I thought like she has computed the intersection point, so that's why I was asking her.
So just try minus 3 comma 2, sir.
Okay, let me check whether this is the intersection point or not. If I substitute minus 1 over here, then I'll get 1 minus 3. I'll do the general process. Just let me take. Okay, so this is fine. This is minus 1 minus plus 5 minus 4. Okay, certainly this is the intersection point. Okay, so generally how you compute the intersection point? Okay, so you just need to compute, you just need to equate both the equation. Okay, 3x plus 2, which is basically minus x square minus 5x minus 4. So if I equate both the equation, then what basically I'm getting? I'm getting 2x square, right? 2x square plus 8x, I guess. Yeah, 8x. Just let me know if I'm doing something wrong. So this is 6 equal to 0. And what I can do, I can take 2 out. So this is x square plus 4x plus 3. So I can factor it out. This is, okay, this is x plus 3 into x plus 1. Okay, so this is 0. So that means x equal to 3 and x equal, sorry,
So
not
minus
x equal
3.
to 3. Yeah, x equal to minus 3 and x equal to minus 1. So if I substitute x equal to minus 1, then I'm getting
0.
0. So that means this point B is basically minus 1 comma 0, because it says that a can't be on the x-axis, right? A can't be on the x-axis. So this point cannot be A. So that means this is my B. This point is my B. Okay, let me compute A. What is A? So for A, I have to substitute minus 3. Correct. So if I substitute minus 3, then what I will get? This is basically 3 square, which is 9 minus 9 plus 2, right? Correct or not?
Yes, sir, it is correct.
Yes, sir.
So you are saying this is minus, so the point is what then? Minus 3 comma?
Minus 3 comma 2.
Minus 3 comma 2.
Yes, sir. So we are getting, right? We are getting the y-intercept as 2, right?
Yeah. Okay, so minus 3 comma 2, nine plus 9, correct. So minus 3 comma 2 is basically in your second
Yes.
axis, right? I understand that this is the intersection, but it's hard for me to believe, like how then the graph.
Yes, sir, it can possible if you draw in Desmos.
Yes, sir.
Yeah.
Personally, I did it on Desmos. It was working.
I also
I'm after
said.
solving.
No. See, solve, certainly you can solve. Okay, that is not a big thing. Okay, I just want to know how it's coming. Oh, probably I'm drawing. Okay, I'm just, let me share the screen. Okay, so just tell me what is the equation. First equation, x square
Plus 3x plus 2.
x square plus 3x
Plus 2.
plus 2. Okay, this is the graph. Okay. And you have another one. What is that?
Minus x square minus 5x minus 4.
minus 5x
Minus 4.
okay, now I can see where I made the mistake. Yeah, correct. So the way I have drawn that graph, that's why actually it was confusing me. Okay, yeah, certainly, yeah, these two graphs can have intersection like this. Yeah, correct. Yeah. Okay, so now, yeah, so now we are fine. Sharing. Just let me go back to the okay, so okay, so let me draw the graph again. So this is probably this is let's say you have this graph. It just goes like this. Then you have another one. This is like this. So this point is basically -1, 0, and this point is this point B is
-3.
comma 2. Okay. So now it's saying, suppose you have a straight line. Okay, suppose a straight line L1 passes through the point A with so L1 is a straight line, okay, which passes through the point A. Okay, so this is one information with slope equal to the slope of the parabola, with slope equal to the slope of the parabola y minus x square minus 5x minus 4 at point A, right? So then what is the slope of the parabola at point A? What is the slope of this parabola?
-2x minus 5.
So,
And
so the slope of the parabola is basically -2x minus 5, correct? So if I substitute -1 over here, then what I will get? It's basically -3, right?
Sir, you have interchanged the names. It should be the B and the A would be -3, 2.
yeah, it's interchange. On x-axis, it's a B point.
Correct. I made mistake. So this is your A and this is your B, right?
Yes.
So okay. So now this L1 passes through the point A, correct? And the slope of the L1 is basically the slope of the parabola at point A. So the slope of the parabola at point A is basically what? 1, right?
Yeah.
So then what will be the equation of the line L1? What will be the equation of the line L1?
So y minus 2 is equals to 1 into x plus 3.
So okay, so the so y equal to mx plus c. So m is basically 1. So this is basically x plus c. Okay, so I just need to substitute this point A. So if I substitute point A, -3, which is equals to 2 plus c, that means
You
c
said
is
2 equal to -3.
minus. So the equation of the line is x y equal to x minus 5, right? This is the line of equation of the line L1, right? Am I correct or not? Hello?
Yes, sir.
Yeah.
So,
Sir, we could use
Try
the slope line form as well, right?
okay. Yeah, sorry.
So we could use the slope point form as well, right? To get the
you can use anything,
Plus C
Oh,
is
okay.
plus 5.
whatever you want. C is, sorry,
Plus 5, sir.
not plus 5. C is
No, sir,
minus.
in this y
Sir,
is
you're
equal
putting
to
a
2.
wrong value,
And
sir.
you-
Y is 2 and X is minus 3.
Okay, it is what you should tell me. Yeah. So at x equal to minus 3, y equal to 2. This is minus 3 plus C. Yeah, correct. Yeah, so y equal to x plus, so L1 equal to x plus 5. Then next says at point A, slope with and two straight line L2 and L3. Okay, this is the equation of L1. So we have two straight line L2 and L3. Okay, both of them passes through the point B, and with slope equals to slope of the parabola y equal to x square plus 3x plus 2 for plus 2
L2.
and y equal to minus x square minus 5x minus 4. Okay, L2 and L3. So this is for L2 and this is for L3 at point B, right? At point B. So B is basically minus 1 comma 0. So what is the slope of this line at B? Sorry, slope of this parabola at B. So B is basically what? So this is y equal to 2x plus 3. And if I substitute minus B, then I will get 1. Correct? Just let me know
Yes, sir.
if I'm making anything. If I'm making any mistake, just let me know. So the slope of this parabola is minus 2x minus 5. Again, if I substitute minus 1 here, then what I will get?
minus 3.
Minus 3.
Minus 3.
So then equation of L2, which is basically the slope is 1. So y equal to mx plus c. So m is 1. So y equal to x plus c. So it is, so the line passes through minus 1 comma 0. If I substitute minus 1 comma 0, so that means c is 1, right?
1.
So,
Yeah,
so the
yes.
line is y equal to x plus 1.
X plus 1.
Correct. So again, next I need to find the equation of the line L3. So this is basically minus 3x plus c. Okay, so if I substitute minus 1 comma 0 here,
C is equals to 3, sir.
3.
c equals to 3. So y equal to minus 3x plus 3. Correct. So now we have equation of all the lines, right? So it is, so the first option says L1 and L2 are parallel. It is correct, right?
Yeah, the slopes are equal, sir.
So the slopes are equal, right? So here the slope of the line is 1 and here also the slope of the line is 1, right? So both are parallel. Next option says L1 and L3 are parallel. So this is not possible. Okay. So L1 and L3 can't be parallel. Okay, because the slope of L1 is 1 and slope of L3 is minus 1. The next option says L1 and L3 are intersecting at minus 2 comma 3. L1 and L3, right? So L1 and L3. So x plus 5 is equals to minus 3x plus 3. That means 4x is equals to so this is what 4x equal to minus 2, right?
Yes, sir.
So that means x equal to minus 1 by 2. So I guess third option is incorrect, right? L is saying that L1 and L3 are intersecting at minus 2 comma 3. So as you can see, they are not intersecting at minus 2 comma 3. They are intersecting at minus half comma something. Okay. L2 and L3 are intersecting at -1, 0.
Yes.
This is correct, right? Because they passes through the point B, right?
Yes, sir.
And B.
-1, 0.
So this is correct. So what about the last option? L2 and L3 are parallel. So this is also incorrect, right? L2 and L3 can't be parallel because they have different slopes. So what is your doubt in this question? Like, so now are you able to understand like what?
Yes, sir. I understand L1 and L3 are L1 and L2 are parallel. But sir, here given answer, accepted answer, L1 and L3 are intersecting at point -2, 3.
Then probably we have made any mistake with the calculation. Just give me a minute. Can you check what is the equation of the line L3, whether L3 is correct? I guess we made mistake with this line.
So
I
that
think
would be -3.
yeah, so C is -3. Okay. So C is actually -3. Okay. If C is -3, then actually we are so
So it's a -8 by -4 or
yes.
8 by -4, whatever that is.
Yeah, so this is 4x is equal to -8, and in that case x equal to -2. So if you put x equal to -2, then you will get what? 3. Okay.
-2. Yeah.
-2, 3. So in that case, option C is correct. Now, is it clear?
Yes, sir.
Yeah.
Thank you, sir.
Yeah. Any other doubt? Okay,
So we have problems to solve, or it is just doubt sections here?
this is just the doubt session. If you have any doubt, you can ask.
So could you take the next question, sir, the third one?
Third one is incorrect. Like so there is a problem with that question. We'll give you the solution. Like third one is actually there can be multiple possibility
Yeah,
for that question.
correct. So
Yeah.
because when you said you are canceling that question, so that means that question, I know it is showing 0 marks. So are you removing that marks from the whole assignment?
Yes.
So we will get extra marks, or it is just like 0,
No,
0?
we'll compute your marks from out of these 8 questions. Okay. Or
Okay,
maybe
sir. Sure. Okay, sir. Thank you.
Yes. Yes.
I have a doubt in week 4. Can I ask?
Yes, please.
Sir, in the week 4, we have, described like how the endpoints of a graph will, change, like how it will be determined. But during that, when it cuts the y-axis, sir.
What do you
so
mean
how
by
can we-
endpoints of the graph? Can you just I didn't understand. Like when you said the endpoints of the graph, or you mean end behavior of the graph? There are
Yeah, like end behavior of the graph. Sorry
yeah.
for that.
Yes.
So, what my main question is like, sir, while we can see, like, there was a, explanation like how it will change its, direction and during like their, like the roots between the roots. But so my point of question is like, how can we determine whether it's gonna cut y-axis or it's gonna like, just touch it? Like, what I mean is like crossing like a straight line or just gonna curve like, in the
Yeah.
sin x.
Understand your question. Just let me tell you with bunch of examples. Okay. So it's basically the cutting, whether it will cut or whether it will go back. Okay. So it's basically depend on the multiplicity of that particular number. Okay. So so let me tell you. Let me take this graph. Let me say f of x equal to x plus 2 whole square times x minus 5, right? So my aim is to draw this graph. Okay, so that is what I want to do. So I want to draw this graph. Okay, so this graph, if I multiply this equation, so I'll get something x cube, right? X cube and some lower term. Okay, and some lower term. And actually to draw the graph, I don't need these lower terms. I don't need these lower terms. I just need the first term, the highest, the x which has the highest power. Okay, and as well as its coefficient. Okay, so as well as its coefficient. So this is basically what 1 times x cube. Okay, can you please mute yourself? I'm getting some noise. Okay, so
I'm muted only.
sorry.
I was muted.
No. I'm not. Okay, I was not saying to you, but I was getting some noise. Okay, from someone. Okay, so this is what I want to compute. So one thing is clear. So this polynomial has two roots, right? This polynomial has two roots. This polynomial has two roots. So one is -2. One is -2 and another one is 5. Now there is a difference between -2 and 5. So -2, it appears twice, right? Because you have a power 2 over here. For -2, you have a power 2 over here. So -2 appear twice, right? -2 appear twice. That means -2, the multiplicity of -2. If you have doubt, please unmute yourself and ask. Okay, so -2 has multiplicity 2, right? -2 has multiplicity 2, and whereas 5, this 5 appears once. Okay, so the power is basically 1, right? So that means the multiplicity of 5 is 1, right? The multiplicity of 5 is 1. So this multiplicity will decide whether the graph of this function will cut x-axis at that point or whether it will bounce back. So that multiplicity will decide. If the multiplicity is even, okay, then the graph will bounce back. Okay, if it is even, something like 0 or 2, 4, 6, 8, if it is even, then the graph will bounce back. Okay, so the graph will bounce back. If this is the point 2, and if his graph is coming like this, then it will not cut 2. It will, sorry, this is -2. Let's say this is -2. This is -2. If graph is coming like that, then it will bounce back. It will not cut x-axis. It will not come to this direction because the multiplicity of -2 is 2 and 2 is even. Okay, so if the multiplicity is odd, then basically it will cut the x-axis at that point. Okay, it will cut the x-axis at this point. So these so the multiplicity actually decides whether at that point the graph will cut the x-axis or whether it will bounce back. So is it clear now? Hello?
Yes, sir. It's clear. But sir, my one more question is like we have seen the behavior of its root while how it's gonna turn up around. But like, what's its behavior at the y point? Like it's gonna cut at y-axis. Like the equation which cuts at y-axis. Is it gonna be like a sines graph or like a linear graph? Like when we see a linear line, it just cuts the y-axis. But in a sines graph, it's just like a curve there. It's symmetric around the y-axis. So how are we determine like it's gonna cut it or like it's gonna be symmetric around that?
What do you mean
points.
by symmetry? Like, so the sign, okay, so I still didn't understand what do you mean when you said the symmetry.
So if you can see the sin x graph, it's
yeah, so
symmetric on the
sign,
y-axis. It's kind of symmetric, like
no,
it
certainly the
bends over y.
polynomial on is not symmetry. Okay, so that is not possible for polynomial. Okay, so this is not
So
symmetry.
it's gonna
Actually,
be useful for while drawing the graph. That's
it's
the main.
yeah, I understand, but okay, so polynomial, I don't know why symmetry is it's periodic in some sense. Okay, uh, okay,
Okay, so
yeah. Something like this, right?
yeah.
Yeah. So what do you mean by okay? In some sense, what do you mean by
Yeah, see,
symmetric?
in this, like it cuts, here, like it cuts at a 0.0, right? Okay, 0,
Mm-hmm.
0. Yeah. So
Mm-hmm.
like if you take another example of cos, it just like bends. This sine curve bends at -1, -1. It bends there, right?
Mm-hmm.
Yeah.
Mm-hmm.
So my question is like, how can we determine like like this graph? It cuts y-axis, na? It doesn't bend there. But in cos graph, it
Yeah,
bends at the
yeah,
y-axis,
yeah. I
cutting at a
understand.
bending. The
So
same thing.
suppose okay. So let me tell you. Suppose you want to draw. So you want to know the points.
Yeah, what happened at the y-axis? Like it is gonna bend and cut there, or just like cut in a straight line form. So that's the main question.
No, it's depend on the route, right? It's depend on the route. Suppose what? Uh, suppose if you take this polynomial p of x equal to x square, right? So
Yeah.
this is your polynomial. If you draw it, you know, like it has only one root, that is 0, right? So it will come like this.
It's gonna bounce back. Yeah.
It will again it will bounce back, right?
Yes.
Because this is what, x minus 0
Yeah.
whole square. Okay, at 0 the multiplicity is what?
Even.
Even, right? So then it will come, and since there is no more root, so it will bounce back and it will go towards infinity, right?
Yes.
So suppose instead of x minus this, suppose I have something like this, x square into x minus 1, right?
Yeah.
So if I draw the graph of this uh, polynomial, okay, so again it will come to 0, right? Because 0
Yes.
is a root, right? 0 is a root. So now what is the multiplicity of 0?
Even.
Even, then that means it will bounce back, right?
Yeah.
So the thing is, it will bounce back, but certainly it can't go towards infinity, right?
Yes, sir.
Because it has one more root, right? Which is 1,
Yeah.
right? So it will
So it will bend.
bounce back, and again it has to bend. Okay, it has to bend, it has to come to this 1 comma 0. Okay,
Yeah.
and what is the multiplicity of 1 here? Multiplicity of 1 is what? Odd, right?
Yes. It's gonna cross.
Okay, I guess this is not the correct way. So let me tell you why, because certainly it can't.
Because the A is positive, sir. So,
Yes, correct.
so it will come from that side
Yes.
first.
So the thing is, okay, so first of all, it will come like this, okay. So it will, so again, it will cross it will cross this 1 comma 0, because multiplicity of 1 is odd.
Okay.
Then again it can't go like this, right?
No.
Because it has one more root, that is 0, right? So then it will come and it will go towards 0, right?
Yes, sir.
So now what is the multiplicity of 0? 0 multiplicity of 0 is even, right?
Yes, sir.
So again it will bounce back. And since there is no more root, okay, to the left of 0, then it will go towards minus infinity. So it's completely depend on your function, okay, and how many roots that function has, okay. So for example, here you have only one root, 0, okay. So it will come and it will reach to this point, then again it will go bounce back and it will go towards infinity. Okay. For this case, so it's depend, like it will come from, because so the thing is, if you see, if x tends to minus infinity, okay, then basically p of x tends to minus infinity, right?
Yes, sir.
So that's why this graph will come from this direction, okay. So the graph cannot come from this direction. So initially we made a mistake. So the graph will come from this direction, okay. So first it will come to 0, okay. Since the 0 multiplicity of 0 is even, it will bounce back. Now the problem is it can't go like this, because you have one more root. So then it will go to 1 and it will cut the x-axis, because the multiplicity of 1 is odd. Is it clear now?
Yes, sir, it is.
But to find out this particular point, the point where actually it started bending, okay, that actually probably it's difficult. You need derivative. Okay. So it's the point, basically it's the turning point. So you need to find the
Where its derivative will be 0.
0, yeah, correct. Because at this point, basically the slope.
One thing, the derivative of a quadratic function shows its slope, right? So what will
Yes.
a derivative of a cubic function will show?
Yes, same for any curve, it will show the slope of the tangent line at that point. Okay, what it doesn't matter, it's quadratic, cubic, polynomial, sine function, exponential function, any function. If you take the derivative, okay. For example, if you take the derivative of the sine function at this point, okay, at this point, it precisely it will give you the slope of this line.
It means like derivative of any polynomial function give its slope at that point.
Yes, slope of the tangent line at that.
Yes, slope of tangent line, sir.
Yes.
Yes, sir. That's all.
Okay, any other doubt? Is there any other doubt, or or anything you want me to discuss? Okay, so the thing is, okay, so let me tell you, okay, if you don't have any doubt, then probably I can close the session. So if you have doubt, please ask. Am I audible or not? Hello?
Yes, sir, you're audible.
Okay. Okay, then probably I'll stop the session now since you don't have any doubt. Yeah.
Okay, sir. Thank you, sir.
Thank you.
For the session, sir.
Yes, thank you.
Thank you, sir.
Thanks.
Thank you so much, sir.
Thank you. So quiz, I guess. Okay, someone asked like how long is the quiz for? Probably it's for 1 hour. Okay, so 1 hour, and the syllabus is basically from week 1 to 4. Ravi, do you have any doubt?
Hello. Hello.
Hi, are we discussing any problem?
I just joined. I do have a problem that I'm struggling with. If anyone can help me with it.
Even I had some queries, so that's the reason I joined. Actually, I'm not that great at mathematics, so I don't know if I'll be able to help you completely.
Oh, okay. Which question are you struggling with? Maybe I know how to solve it.
Yeah, sure. Actually, this was from week 3. 1 second, I'll just fill up the.
Can you type in the chat which problem in the week 3? I'm actually also like solving week 3 right now. I did have a problem with a question.
Yeah, just 1 second. One, two, three questions, but if you are discussing week 3, then I wouldn't mind discussing the entire paper also. Otherwise, 1, 2, 3 at least.
You're talking about graded assignment?
Yeah, graded assignment.
Okay, so first one I did solve. Okay, so first one, like without giving the whole answer, I would say the x coordinate of the vertex. So first of all, you will find the vertex. Well, let me check my notes. 1 second. Since we know that the hello.
Yeah.
Am I not audible clearly? Do you want me to type it?
No, I can hear you. What I'm trying to say is that we have already completed the assignment, right? So if we can go, see, I'm sharing the screen. If you can explain the working.
Okay. I actually did not submit the assignment. That's why I'm solving it today. But I will. But I can tell you how you can solve the first problem. Okay. Should I share my? Okay. So in the first problem, you already know that the vertex is at 3. The value of x-axis at the vertex is 3. It is given, right, in the second part of the sentence. So what that means is that remember from earlier our lectures that the vertex is given by minus b by 2a. So basically minus b by 2a is equals to 3. Okay, so now now that you have this condition minus b by 2a is equals to 3, now you have 4 equations in front of you. Now one by one try inserting the value of b and a and into minus b by 2a, and if that results in 3, that means it passes the condition. It passes the first condition. Okay, So you will
2x square plus 3x plus c, that way, is equal to 5, that way.
that is about slope. No, I'm talking about the second condition it has, the x coordinate of the vertex of the parabola is 3.
Okay.
Okay, wait. I'll share my screen. Is that okay? Okay, entire screen. Let me know if you can see my screen.
Yeah.
Okay, so let's come here. Let's look at this. One sec, let's solve this. Let's copy this problem. Copy. Let's come to the latex. This is graded assignment, right? So just give me one moment. Okay, where are we? It's not here. Where did it go? If the slope of the parabola contains 0. You know what? Let's just come here. Okay, it's here. Yeah. So let's say we have this problem. So first of all, we can say what the given is because of the conditions and x coordinate of the parabola is given. Since x coordinate of the parabola is 3, we can say